All right, today we're going to do classifying quadrilaterals. Our learning target is I can classify quadrilaterals using their definitions and coordinate geometry. Our first example wants us to use the definitions of each quadrilateral to determine whether the following statements are sometimes, always, or never true. I want you to try to figure out if it's sometimes, always, or never true by pausing the video and trying A, B, C, D, and then start the video to see if you were correct. So go ahead and pause the video. All right, now that you're back, a square is always a rectangle. The only stipulation to be a rectangle is 4 congruent angles, and a square has 4 congruent angles. So a square is always a rectangle. A trapezoid is never a parallelogram. The stipulation to be a parallelogram is 2 pairs of parallel sides, and trapezoids only have 1 pair of parallel sides. So it can never be a parallelogram. A parallelogram is sometimes a triangle. Okay. Both have 2 pairs of opposite sides congruent, but a rectangle has 4 congruent angles. Now we're talking about a parallelogram being a rectangle. I could have a rhombus, and that's also a parallelogram because I have 2 pairs of opposite sides parallel. So it doesn't always have to be a rectangle. I could have a rhombus or a square to be a parallelogram. A parallelogram has diagonals that bisect angles, and that's only sometimes because in all of my parallelograms, they don't always bisect the angles. In a rectangle, the diagonals do not bisect the angles, but in a rhombus, they do. Now for example 2. Again, I want you to figure out what's the most descriptive name for the quadrilateral by first pausing the video, you trying the problem, and then unpausing the video and seeing if you were correct. So go ahead and pause it. All right, now that you're back, I actually want you to skip A because we don't have enough information. But in B, that should be an isosceles trapezoid. The stipulation to be an isosceles trapezoid is legs are congruent, which I have, and opposite sides parallel. So the most descriptive name I could give is isosceles trapezoid. In letter C, the most descriptive name I can give is a rectangle. Okay, I have all parts here congruent, meaning that the diagonals are equal and they bisect each other. So the most descriptive name I can give is a rectangle. A square would be too specific because I would need to know that all the sides are equal, and I don't know that. So a rectangle is the broadest term while also being descriptive. Letter D is a kite because remember, in a kite, only one diagonal is cut in half. So that makes letter D a kite. In letter E, I have consecutive interior angles here, which forces these sides to be parallel because these are supplementary when I add them together. 90 plus 90 is 180. So this is a trapezoid. In letter F, I have 4 congruent angles. That's the only stipulation I need to classify a rectangle. So letter F is a rectangle. In letter G, I have 90-degree angles, meaning that the diagonals are perpendicular. The only shapes that do that are a rhombus, square, and a kite. It is not a kite because both diagonals are being bisected. And since they're not all equal, it's not a square, so I'm left with a rhombus. All the diagonals would need to be equal if it was a square, all the diagonal segments. And H is a kite because I only have one diagonal cut in half. It's the only information I have, so that is a kite. So you should be going to your flow chart, and we're going to fill that in. Now we're going to fill in the boxes, and anything that we fill in the empty boxes is what I'm going to give you on the test. But again, you need to know what those questions mean, what they're asking you to find. So below the empty boxes in red, I'm going to mark that. Just keep in mind that red ink will not be on the copy I give you for your test. So the first question in our flow chart is talking about two pairs of opposite sides parallel. Okay, so if they're parallel, what that means is that the slopes are the same. Okay, so this red ink won't be on the flow chart I give you for the test. So you have to know when I ask, are two pairs of opposite sides parallel? I'm asking you to find the slopes and determine if they're the same slope. Okay, because I will be giving you problems with I give you the slopes, or I'll be giving you problems where I give you the points and you're going to find the slope and determine if you have two pairs of opposite sides parallel. If your answer is yes to that question, the next question you're going to ask yourselves is, do I have four right angles? Okay, which means you're looking for slopes being opposite reciprocals. Okay, that means that the slopes are opposite signs and the fractions are flipped. If you say yes to that there's four right angles, you're going to ask yourself, are there four congruent sides? Okay, when I ask you about the sides being congruent, you're always going to use distance formula to figure that out if you have to. Some examples, I give you what the links are. If you say no to four right angles, you're again still asking yourself, are there four congruent sides? And you're also using distance formula to figure that out. If there are four right angles and there are four congruent sides, so you say yes to both of those, you will classify the quadrilateral a square because you need four right angles and four congruent sides to be a square. If you say yes to four right angles but not four sides congruent, then you're going to classify your quadrilateral as a rectangle. If you say no to four right angles and yes to four congruent sides, you're going to classify your quadrilateral as a rhombus. If you have four congruent sides, four right angles, if you don't have four right angles and you don't have four congruent sides, you are going to classify your quadrilateral as a parallelogram. So that's the top half of the flow chart. That's if I have two pairs of opposite sides parallel. If I go back to the beginning of the flow chart and I actually say no to the first question, meaning I don't have two pairs of opposite sides parallel, the next question you're going to ask, do I have one pair of opposite sides parallel? Okay, that is still checking to see if slopes are the same. If you do have one pair of opposite sides parallel, you're going to ask yourself if the legs are congruent. Now, when I talk about legs, I'm talking about the non-parallel sides. Again, because we're talking about length, you're going to use distance formula. If you do have legs congruent, then that's going to be an isosceles trapezoid. If you don't have legs congruent, that's just going to be a regular trapezoid. Now, if you don't have any sides that are parallel, none of the slopes are the same, your next question is going to be, do I have two consecutive sides congruent? And again, that's going to be using distance formula. And remember, when I say consecutive, I mean two sides that are right after each other. If they're both congruent, then that figure is going to be a kite. If you say no, then the most specific name I could use is a quadrilateral because it has four sides, but it doesn't have any of the special properties, not even a parallelogram property. So what we're going to do is we're going to use this flow chart to do the problems when I give you points, or when I give you the slopes and the side lengths. So let's go back to our notes. Okay, when given coordinates of the vertices, you are going to use your flow chart to classify the quadrilateral. Now, in example 3, I don't have to use any of the distance formula or the slope formula because I give you what the slopes are of the segment sides, and I give you the lengths of the segment. Okay, I always like drawing a sketch, and I make it look like a parallelogram because I'm not really sure what it's supposed to look like. Just make sure right here that you're going in order as you go around the quadrilateral. Okay, you got to go in a clockwise motion and don't skip any vertices when you label it. If you do, then you're going to probably get a wrong answer. So the first question on my flow chart is, do I have two pairs of opposite sides parallel? Which means I need to look for slopes being the same. So these two slopes are the same, meaning that these two sides are parallel. So OU is parallel to ST. And these two slopes are exactly the same, meaning that these are parallel. So UT and OS. So I do have two pairs of opposite sides parallel. So I'm going to say yes to that. The next question on my flow chart then takes me to 4 right angles. For 4 right angles, I need to have slopes that have opposite reciprocals, so that they have opposite sides, which I do. This is positive and this one's negative. And the fraction's flipped. It has to have both. And it is flipped, so I have perpendicular. These two are also perpendicular. So OU and OS make 90 degrees. And ST and UT make 90. So I have 4 right angles. So I'm going to say yes to that on my flow chart. When I say yes to that, it takes me to the next question, which is 4 congruent sides. So that's when I start to look at the lengths of my segments. Okay? OU is square root 10, and UT is square root 5. All I need is one example of it not being equal, and I know that not all 4 sides are equal. So I will say no to that, and that leads me to my answer being a rectangle. And making sure we don't forget to put 4 right angles here. Okay. But what do I do when my example doesn't give me those slopes and side lengths, and only gives me the points of the vertices? Well, that's when slope formula and distance formula comes back into play from first semester. So again, I like to draw a just random parallelogram because I don't know what it's going to be. And I'm labeling it in clockwise order, not skipping a vertex at all. Okay. First thing I'm going to do, on my flow chart, it asks 2 pairs of opposite sides parallel. So for me, I need to know if slopes are the same. Well, I need to know what the slopes are, so I'm going to have to find them first. So I'm going to find the slope of PQ first. Remember, check on top and bottom. This is my x1, y1. This is my x2, y2. Remember, it's y2 minus y1 over x2 minus x1. When I type that into my calculator, I get a slope of 2 over 1, or 2. Then I do the slope of SR. And I'm following the same formula. So I'm going to have 2 minus 0 over 6 minus 5. I get 2 over 1, or 2. Then I do the slope of QR. 2 minus 3, 6 minus 4. When I find that slope, that's negative 1/2. And the slope of PS is 0 minus 1 over 5 minus 3, giving me negative 1/2. So now that I have the slopes, I can answer the first question on my flow chart. 2 pairs of opposite sides parallel, so are the slopes the same? Do I have 2 pairs of slopes the same? And I do. So I say yes to that. And the next question I'm supposed to ask myself is, do I have 4 right angles? Okay, so now I'm looking at my slopes and I'm trying to figure out, do I have opposite reciprocal slopes? If I look here, I'm looking for 1 positive and 1 negative, which I have, and I'm looking to see if it's flipped, which it is. So that's perpendicular, and those are perpendicular. So I do have 4 right angles. Oh, and I forgot to mark, I do have my parallel sides. Okay. So I say yes to 4 right angles. That leads me to saying 4 congruent sides. And if I look at my chart, it says I'm supposed to use distance formula. So now to find the lengths, I have to use distance formula. Okay, if you don't remember distance formula, the distance equals the square root of x1 minus x2. Actually, it's x2 minus x1. x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm going to find the length of PQ. So my x2 is 4 minus my x1, which is 3. And I square it. Then I add it to my y2, which is 3. Minus my x1, which is, my y1, which is 1. Okay. All I do is type that whole thing in my calculator, making sure to use parentheses where I wrote my parentheses, and I get the square root of 5. Okay. Now I do distance formula on all the sides. So for QR, I have 6 minus 4 squared plus 2 minus 3 squared. And that also gives me square root 5. And then I do SR, which is 2 minus 0 squared plus 6 minus 5 squared, which also gives me square root 5. And I do PS last, and it's 5 minus 3 squared plus 0 minus 1 squared equals square root 5. So yes, I have all 4 sides congruent. So when I say yes to that, it leads me to say that this is a square. You should have a worksheet that says more quads review or practice. You're now going to work on that. They have problems like this. They have problems from our notes that we had the last couple of days so that you can practice. The answer key is on Google Classroom so you can check your answers as you work. Have a good day.